realize it, but your question went right into what we're doing today. Describe the motion, describe vertical motion. So we're going to practice that again. So that was really good that you got into number 22. So thanks for that. And how to read and interpret velocity graphs. Okay. It is going to be really important that you understand what you are looking at. You will always be told the context of the question. So for example, the context of this question is that you are looking at the graph of position. Position is always the original function, the original f of x. The table below, we are asked about velocity. And as we have learned, okay, velocity is the same as what calculus term? Let's try that again. Velocity is the same as what calculus term? Derivative. Okay, velocity and derivative are the same thing. Derivative is the same as what other mathematical term? Slope, okay? So we are being asked from a graph to describe what's going on the slope. Okay, when you fill out and read charts like this, you don't need to figure out the exact value of the slope. You just need to indicate whether it's a positive number or a negative number. All right, so between the numbers of -3 and -2, which would be this region right here, what type of velocity do we have? And in your mind, you're replacing the word velocity with derivative, and then in your mind, you're replacing the word derivative with slope. So in that interval, what kind of slope do we have? Positive, which we interpret then as the motion going either up, if the problem tells us that this is a vertical problem, or the motion going to the right, if this is a problem that says we're going in horizontal directions. Okay, between -2 and -1, what kind of velocity do we have? We have negative. Also, between 1 and 0, we have -1 and 0, also between 0 and 1. Okay, so what can you tell me happened right here at that instant moment of -2? Change direction. Okay, it was at rest and it changed direction. Okay, so exactly at that moment. So we have either right or up. Right, and then we have a change of direction, and we have either down or left for a while. Okay, now let's get to 1 to 2. What is going on? What type of velocity do we have between 1 and 2? And remember, the word velocity is the same as derivative, and derivative is the same as slope. We have 0. What does that mean? If it has 0 velocity or 0 derivative or 0 slope, it's not moving. For that whole time, it's standing still. It is at rest for the entire duration of that. When does it start moving again? Okay, from 2 to 3, it starts moving again. And from 2 to 3, it starts moving in a positive direction. And from 3 to 4, it continues moving in a positive direction. Then we have a little section where it's not moving again. Between 4 and 5, not moving. And then we have between 5 and 6, and 6 and 7, it moves in a negative direction. So you're telling a story off of reading a graph. These are the easy ones. Because the graph is the position, and the chart is the velocity, and these are the easy ones to read. It gets harder. Okay, so that would be from like a basic physics class. Maybe later on in the year, then you would get to here. Okay, if we want to draw a velocity graph, this ties into this question on your quiz, that one. Okay, I was getting you ready to learn how to draw a velocity graph. All right, if this is the original function, then how do you create a graph of the derivative, which is a graph of the velocity? So this is where you actually need to know the value of the slope. So as I'm drawing a graph of velocity, I would go like this. Okay, this is a slope of 1. So its velocity, if I'm superimposing it right on here, would be right there at a value of 1. And some of you got this right, but some of you weren't paying attention. Closed circle, open circle. The next segment has a velocity slash derivative slash slope of -1. So I do a segment of -1. The next piece continues to be -1. And the next piece continues to have a slope of -1. So all of the open circles correspond with where there's a corner on the graph. The next piece, the next segment, has a slope of 0, so I draw a segment of 0. Okay, the slope turns into the segment. The next segment has a slope of 2, which turns into a segment of 2. And then again, another segment of 2 followed by an open circle because I arrive at a corner. The next segment has a slope of 0, so that becomes a segment of 0, followed by 2 segments of -1, and I end with a closed circle on the end. Always closed on the end points and open. That is now a graph of the velocity. And so this velocity graph tells the story. You can see that from segment to segment, okay, that represents, because it was a velocity that was above the x-axis, that represents going up. Then I change direction, and now I'm below the x-axis, and this would be going down. So we've got up and then down. Then we're followed by a rest. Almost like if you read music, okay, you know that there are rests built into music, whether that's a quarter rest or a whole rest. Okay, then we're going to go up again for a while. Then we rest again. And then we go back down. The length of this segment tells you how long that was happening for. So I was going up for 1 second. I'm going down for 3 seconds. I'm resting for 1 second. I'm going up for 2 more seconds. I'm resting for another second. And then I'm going down again. Okay? Telling a story. So it could be like a squat or a wall Pilates or something. And you're like, okay, you're doing it. Okay, now rest. Okay, now do the opposite side. Okay, now rest. Okay, it could just be telling that story. Okay, speed. How did you learn yesterday, overnight, what the definition of speed is?
Distance over time.
Oh, that's not a calculus definition.
Absolute value of velocity.
Yes, okay, the speed is the absolute value of the velocity. Okay, the absolute value of the velocity. When absolute value does what to every positive number? Keeps it the same. What does an absolute value do to every 0? Keeps it the same. What does an absolute value do to every negative number? Makes it positive. So if you were going to convert this to a speed graph, you would have to take any of the down sections and move them up to a positive number. And so if we were doing speed, our speed that would be fine because it's positive. This 0, 1 would be fine. This positive one is fine, and this rest one is fine. Those are all fine when you're creating a speed graph. What's not fine is when you have negative sections. So I take the sections that are down and I move them up above the x-axis. That would be the graph of a speed graph. Okay, taking the 2 down sections and just sliding them up to their corresponding parts. Speed cannot tell you direction. Only velocity can. Velocity includes direction. It's a vector. Velocity has a sign. It's either positive or negative, which can tell you the direction something is going. Speed doesn't. Okay, my speed, if I say from my house to here, I went an average of 35 miles an hour. That's just a speed. That doesn't tell you whether I went east or west or north or south, because I didn't tell you a direction. I just gave you a speed. All right, here we go. Now, What if I give you a graph and I tell you you're not looking at a position graph anymore, you're looking at a velocity graph? Okay, you are looking at a velocity graph. So the slope analysis of this is going to tell you about the acceleration. It's not going to tell you about velocity anymore. So in our chart now, I've divided up and I've given you a new row for acceleration. So the same analysis that you just did about pluses and minuses are now going to tell you about acceleration. All right, so let's try that. Let's go segment by segment. Let's look at this first segment between -3 and -2. What is its derivative? And remember, what do you replace the word derivative with? Okay, its derivative is, I don't even need to know a number. I just need to know that it's negative. Okay, so where do I put a negative sign in my chart? Under the A, because I am looking at a graph of velocity, therefore, its slope tells me about acceleration. Okay, then my next segment switches and it's going to have a positive slope. This whole next segment here has positive slope, so that'll be 3 positive sections in a row, which means 3 positive accelerations in a row. For those of you who drive, this is the difference between putting on the brake and putting on the gas. Okay, so if the A is negative, you're putting on your brake. If the A is positive, you're stepping on the gas. Now we have a section, this is interesting. What kind of derivative does that have? Has a 0 derivative. So in my driving analogy, what does that mean? I'm coasting. Does it mean I'm stopped? Does not mean stopped. It means I'm coasting. Maybe I've set cruise control or something. I'm neither slowing down nor speeding up. I am staying at the same rate. All right, now this whole next section here, it's going down. That's 2 units of time, 2 seconds worth of time. Then I'm going to coast for a while. So in other words, I'm putting the brake on, coasting for a while. And then my last 2 segments, I'm putting the gas back on again. Acceleration tells you the feeling of whether you're slowing down or speeding up. Okay, that's what acceleration does. Now I'm going to erase all this. Now I'm going to fill in the top row. Filling in the top row of velocity, when you're looking at a graph that's already velocity, all that does is ask you whether it's below or above the x-axis. It's not asking you whether it has what its slope is. We've already done its slope. We just want to know, is it above or below the x-axis? So in this segment here, I am below the x-axis, so that counts as a minus. In the next segment, I'm still below the x-axis, so that counts as a minus. I don't change. In fact, if you've taken physics, you might even know about, like, you guys are calculating area and stuff like that. Like, this whole section is below the x-axis. I should have colored that red to match. Okay, this whole section is below the x-axis, so that's all minus. This whole section here is also below the x-axis, so that's starting at the number 3. So those are all minuses as well, because they are all below the x-axis. The only parts that are positive are the section here, and these would all have positive values. All right, the reason we line up velocity on top of acceleration is because the combination of pluses and minuses are going to tell us something else important about this. All right, I've translated this on the next slide. Those are the same numbers, okay? So I already have it on here. Okay, question. When does the particle change direction? All right, now remember, which of the 2 physics things tells you about direction? No, acceleration does not tell you about direction. Only velocity can tell you about direction, okay? Acceleration tells you about the feeling of stopping, like slowing down and speeding up, but changing direction, you have to check velocity. Bye. A change in direction always means a checking of velocity. And we want to identify where it changes direction. In other words, on my row for velocity, where did the plus change to a minus or the minus change to a plus? So hopefully you see that right here, where the minus changed to a plus. And then we should see it again right here, where the plus changed to a minus. I'm changing direction 2 times. And so we would say at t equals -1, and again at t equals 3, because the sign of the velocity changes. That's how we know we're changing direction, because the sign of velocity changes. Okay. When is the particle going to the right? Again, this is a direction question, so we want to check velocity again, because velocity is a direction vector. Going to the right is during, okay, can anybody give me the interval? When is it going to the right, Andre?
-1 to 3.
Okay, from -1 all the way up until 3. Please don't include -1. It's not -1 inclusive, and it's not 3 inclusive. I don't put the bar underneath, because we already said at -1 it was changing direction, so it can't be going to the right then. It's only going to the right during that interval, because the sign of v of t is positive. And then it's going to the left during, and then we have 2 intervals it's going to the left. It's going to the left from -3 up to -1, and it's also going to the left from 3 till the end, 3 to 7, and you would say because the sign of v of t is negative. These are called justifying your answers, giving a reason for why it is what it is. In my experience, it is much easier to answer questions like this if you have made a chart from the graph. If you take the time to make a plus-minus chart off the graph, just like we did, okay, if you take the time to analyze the slope, and you take the time to analyze the areas that are above and below the x-axis, answering the questions becomes a lot easier. Okay, here it's the same. I just copied it again so that we could see this. All right, this is an interesting, yeah.
What about stopped?
Oh, I'm sorry. Stopped, it would be the same answer as when it was changing direction at -1 and -3 for the same reason, okay? Okay, this question of speeding up and slowing down. A lot of people make the mistake of thinking that they have to check only acceleration. But I'm going to tell you that you have to check both. Both things contribute to the feeling of speeding up. Now, there's obvious times you're speeding up. Let me tell you where those are. It's right here. You got a double-double, okay? Where you have positive velocity and positive acceleration. That is definitely the feeling of speeding up, okay? That double-double. But there are other places where you have double-doubles as well, even if they're both negative. Here's a double-double, double negative, and here's another double-double. Anything with the signs being the same will give you the sensation of speeding up. Okay, let me give you an example of a double negative. Someone who jumps out of an airplane with no parachute. Okay, what direction are they going?
Down.
Down. what's happening as they go down? They're getting faster and faster and faster because what's pulling them down? Gravity. Those are two double negative. Their direction is negative and their acceleration due to gravity is negative. But what are they feeling like? Their feeling is, I'm speeding up. The ground is coming at me faster and faster and faster. Okay, they are gaining speed even though it's a double negative. So speeding up would be anytime you have matching signs, the double. Okay, so we're going to say from -3 to -2 and -1 up to +1 and 3 to 4. Speeding up. Because velocity and acceleration share signs. They have the same sign. Okay, they are either both positive or both negative. Slowing down is going to be the times where the signs are opposite. So we're going to be slowing down in the interval where we have the combination of a plus and minus. Not a plus and a 0, but it's got to be a plus and a minus. That is going to be the sensation of slowing down because the forces of velocity and acceleration are working against each other. And when the forces are working against each other, you're going to slow down. If the forces are working together, you're going to speed up. The forces are working against each other, we're going to slow down. And so then we would say from -2 to -1, and from 2 to 3, and from 5 to 7. Slowing down because V of t and A of t have opposite signs. The intervals of coasting should be clear. Whenever acceleration is 0, then you are coasting. You can say I'm coasting in this direction, or I'm coasting in that direction. So we're talking about from 1 to 2, and again from 4 to 5. And we are coasting because A of t equals 0. In one of them, we're coasting in a positive direction, and the other, we're coasting in a negative direction. All right, how you doing? Have I lost anybody yet? It takes a little bit to wrap your mind around all of this. Just takes experience and practice. All right, so here's kind of a, oh yeah, sorry. All right, here's our last velocity graph we're going to look at. Okay, I'm going to do the velocity. This is already a velocity graph. So I'm going to find my velocity by looking at my area. So that whole region is above the x-axis. So I'm going to do pluses all the way across my chart, all the way until I get to the number 7. I'll also have a plus between 9 and 10. Those are my two positives. My negative would be from 7 to 9. Okay, that's how you do velocity off of a velocity graph, a graph of velocity. Now to do acceleration off this graph, I just need to consider segment by segment what kind of slope it has. So if I consider segment by segment, okay, this segment right here has a positive slope. It's curving, but it's still positive. And then the next segment continues to be positive. The only other place I have positive slope is 9 to 10. That's the only other place where my graph is going in a positive direction. Otherwise, from 2 to 4, okay, this 2 to 4 segment, that'll be negative. What about from 4 to 6? 0 slope from 4 to 6. Make those black.
What about from 8 to 9?
Oh, yeah. 8 to 9 is positive, thanks. Yep, this one's positive also. Okay, and then what do we have? 6, 7, and 8 are negative. All right, so there's my graph. Once you've got that, you can tell me all kinds of stories. Okay, you can look for double doubles. Double doubles will tell me when it's speeding up. Zeros will tell me when it's coasting. You can tell all different stories once you've got the comparison of velocity and acceleration at the same time. All right, so here's our last couple slides. I put those same numbers on there. Okay, somebody raise your hand. Who can tell me when this particle changes direction? Not Andre, you already answered one. Sean?
At 7.
Why?
Because the velocity changes sign.
Great. Okay, you can write that down. Times 7 because the velocity changes direction. All right, who's got when is this particle going up? Ian.
At 9.
Say that again.
At 9.
Where else? There's lots of places this particle is going up.
1 to 7.
Not even 1 to 7. I would argue starting at 0. Okay, the interval starts at 0. I've got a plus, all my pluses. So it starts at 0 and it ends at 7. 0 to 7 because that all has positive velocity. When else is it going up, Ian?
9 to 10.
Yeah, these are intervals. Okay, so 0 to 7, 9 to 10. It's going down between 7 and 9. When it stopped is the same answer as when the particle changed direction. Okay, so it changes the direction at 7. It also changed the direction at 9. Both times it changes direction. But be able to answer why. Okay, last one. When is the particle speeding up? This is our last slide. Okay, what are we looking for in speeding up? Same sign, double doubles. All right, Luke, you got it? When is it speeding up?
From 0 to 2.
Uh-huh.
And from 9 to 10. And 7 to 8.
Oh, good job. I'm glad you got the 7 to 8, okay? And the 7 to 8. Okay, 0 to 2 is speeding up. 7 to 8 is speeding up. 9 to 10. Can you articulate why? Because?
The velocity and acceleration are going the same direction.
Have the same sign, right? Share. They're not going the same direction. Don't use the word direction because acceleration doesn't have direction. Velocity does. Say that they share the same sign, okay? Slowing down would be when they don't share the same sign. So that would be 2 to 3, 3 to 4, 6 to 7, and 8 to 9. And then coasting are our sections where we have 0 acceleration. The book is not going to tell you to make charts. I'm going to encourage you that is the best way to answer questions. I think you'll find yourself much less frustrated if you make yourself a chart. Okay, and have the ability to see the pluses and the minuses and compare them. All right, that's my best encouragement to you. Also, I would say on the AP exam, making a chart is super valuable, but they won't give you any points for it. The only points you get are for your explanation. All right, you may use a chart to help you out all you want, but you only get points for what you look for explanation. If you want to take your quiz with you now, we can go over them on Friday, but if you want to take it with you, I'm happy to give it to you right now.